Hi! Today we will learn about simplifying radicals by reducing the radicand. We also call it removing perfect nth powers. A radical expression is said to be in its simplest form whenever the following conditions are satisfied. First, radicand is the smallest possible integer, and the radicand must be an integer that does not contain a perfect nth factor other than 1. Next, there is no fraction in the radicand or the denominator is not a radical. Third, the index of the radical has been reduced. Simplifying radicals. There are three ways of simplifying radicals. First is by removing perfect nth powers or reducing the radicand. In here, we break down the radicand into perfect and non-perfect nth powers and apply the property the nth root of AB is equal to the nth root of A times the nth root of B. Next is reducing the index to the lowest possible order. In here, we express the radical into an expression with a rational exponent, then simplify the exponent or apply the property the mth root of the nth root of A is equal to the mnth root of A and is also equal to the nth root of the mth root of A. Third is by rationalizing the denominator of the radicand. Rationalization is the process of removing the radical sign in the denominator. In this video, we will focus on the first one, which is simplifying radicals by removing perfect nth powers or by reducing the radicand. Let's have some examples. So to reduce a radicand means to find a factor of the radicand whose indicated roots can be found. So for example number 1, we have square root of 63. So here, we're going to think of a factor pair of 63 wherein one of the factors is a perfect square. So we have square root of 9 times 7. Applying the law of radical, this is the same as square root of 9 times square root of 7. And then, for square root of 9, we have 3. Bring down square root of 7. Therefore, the square root of 63 is 3 times square root of 7. There is an alternative solution for this. So what we're going to do is we will get the prime factorization of 63 using factor 3 method. So think of a factor pair of 63. Let's say we have 9 and 7. For 9, we have 3 times 3. Then after that, let us emphasize all its prime factors. So the prime factors of 63 are 3, 3, and 7. After that, identify a pair of the same prime factors and write it once. So here, one pair of prime factors, we have 3. So we're going to write it once. And then the factor that has no pair, it will be left inside the radical sign. The 7 has no factor, it has no pair, so it will be left inside the radical sign. Therefore, 63, the square root of 63 is 3 square root of 7. Let's have another example. Let's say we have the cube root of 81. So what we're going to do is we will think of a factor pair of 81 in which one of the factors is a perfect cube. So for 81, we have 27 times 3 because 27 is a perfect cube and 27 times 3 is equal to 81. Applying the law of radical, this is the same as the cube root of 27 times the cube root of 3. After that, let us now simplify. So the cube root of 27 is 3 because 3 raised to the third power is 27. And then we bring down cube root of 3. So therefore, the cube root of 81 in simplest form or simplified form is 3 cube root of 3. So another method is by using the factor tree method, or getting the prime factors of 81. So for 81, one of its factor pairs, let's say we have 9 times 9. And then for 9, we have 3 times 3. Let us identify the prime factors. So we have 3, 3, 3, and 3. So since we are looking for the cube root of 81, so we need to identify 3 same prime factors. 1, 2, 3. So we're going to write it once, and then the factor which has no pair will be left inside the radical sign. So as you can see, we have the same answer, 3 cube root of 3. Let's have another example. Let's say we have the square root of m raised to the 7th power. So here, we will think of a factor pair for m raised to the 7th power, in which one of the factors is a perfect square. So we're going to have m raised to the 6th power times m. Applying the law of radical, this is the same as the square root of m to the 6th power times the square root of m. Now we can extract. So the square root of m raised to the 6th power is simply m raised to the 3rd power. So you can just divide the exponent by the index. So here the given index is 2. So we have 6 divided by 2. That is why we have 3. And then we bring down the square root of m. We can no longer simplify square root of m. So therefore, the square root of m raised to the 7th power in simplest form is m cubed times the square root of m. Let's have another one. So let's say we have the square root of 80, a to the 4th power, b to the 11th power. So let us think of a factor pair of 80, wherein one of the factors is a perfect square. So we have 16 times 5. And then a to the 4th power times b raised to the 10th power times b raised to the first power. As you can see, we split b raised to the 11th power into b raised to the 10th power times b in order to extract b raised to the 10th power. Applying the law of radical, this is the same as the square root of 16 times the square root of 5 times the square root of a to the 4th power times the square root of b to the 10th power times the square root of b. So the square root of 16 is 4. Bring down square root of 5. We can no longer extract this or simplify. The square root of a to the 4th power is a squared. The square root of b raised to the 10th power is b raised to the 5th power. We simply divide the exponent by the index. 10 divided by 2, so we get 5. And then bring down square root of b. So let us simplify our answer. So we have 4a squared b to the 5th power times the square root of 5b. Another example, let's say we have the cube root of 108, x to the 4th power, y raised to the 8th power, times z raised to the 11th power. So first, we will think of a factor pair for 108, in which one of the factors is a perfect cube. So we have 27 times 4, since 27 is a perfect cube. And then for x to the 4th power, we write x cubed times x. For y to the 8th power, we have y raised to the 6th power times y raised to the 2nd power. And then for z to the 11th power, that will be z raised to the 9th power times z raised to the 2nd power. Applying the law of radical, this is the same as the cube root of 27 times the cube root of 4 times the cube root of x cube times the cube root of x times the cube root of y to the 6th power times the cube root of y squared times the cube root of z to the 9th power times the cube root of z squared. Let us simplify. The cube root of 27 is 3. Bring down cube root of 4. The cube root of x cubed is simply x. Bring down the cube root of x times, so the cube root of y to the 6th power is y squared times, bring down the cube root of y squared times the cube root of z raised to the 9th power is z raised to the 3rd power. And then bring down cube root of z squared. So it means that in simplest form, we have 3xy squared z cubed times the cube root of 4x y squared z squared. Let's have another one. The cube root of 32 x to the 4th power. So let us think of a factor pair of 32 wherein one of its factors is a perfect cube. So we have 8 times 4 since 8 is a perfect cube. And then for x to the 4th power, we will split it into x cubed times x. Since x cubed times x is equal to x to the 4th power. And then we can extract the cube root of x cubed. Okay, applying the law of radical, this is the same as the cube root of 8 times the cube root of 4 times the cube root of x cubed times the cube root of x. So the cube root of 8 is 2. Let us bring down cube root of 4. The cube root of x cubed is x. Then bring down cube root of x. Therefore, we have 2x times the cube root of 4x. Okay, let's have another one. So we have, let's say, the square root of 125, x to the 7th power, y to the 15th power. So let us think of a factor pair of 125 in which one of the factors is a perfect square. 125 is the same as 25 times 5. So we will split x raised to the 7th power so that one of the factors is a perfect square. So we have x to the 6th power times x. Same with y raised to the 15th power. We have y raised to the 14th power times y. This is the same as the square root of 25 times the square root of 5 times the square root of x to the 6th power times the square root of x times the square root of y to the 14th power times the square root of y. So the square root of 25 is 5. Bring down square root of 5. The square root of x to the 6th power is x raised to the 3rd power. Bring down square root of x. Square root of y to the 14th power is y raised to the 7th power. And then bring down square root of y. So therefore, in Therefore, we have 5x cubed y raised to the 7th power times the square root of 5xy. Let's have another one. Square root of 18 x to the 6th power y to the 11th power. So a factor pair of 18 wherein one of the factors is a perfect square is 9 times 2. X to the 6th power is a perfect square, so no need to think of a factor pair for it. And then for y raised to the 11th power, we have y raised to the 10th power times y. So we have square root of 9 times square root of 2 times square root of x to the 6th power times square root of y to the 10th power times square root of y. Square root of 9 is 3. Bring down square root of 2. And then we have x raised to the 3rd power. The square root of y to the 10th power is y raised to the 5th power. Bring down square root of y. Therefore, in simplest form, we have 3x cubed y raised to the 5th power times the square root of 2y. Another example, square root of 8 x to the 5th power, y to the 6th power, z to the 13th power. So a factor pair of 8, wherein one of the factors is a perfect square, is 4 times 2. For x to the 5th power, we have the factor pair x to the 4th times x, since x to the 4th power is a perfect square. For y to the 6th power, we simply bring it down or copy. And then for z raised to the 13th power, we have z raised to the 12th power times z. This is the same as square root of 4 times square root of 2 times square root of x to the 4th power times square root of x times square root of y to the 6th power times square root of z to the 12th power times square root of z. The square root of 4 is 2. Square root of x to the 4th power is x squared. Square root of y to the 6th power is y cubed. And the square root of z to the 12th power is z to the 6th power. So we have 2x squared y cubed z raised to the 6th power times the square root of, so we will just simply copy square root of 2xz, since we can no longer simplify them. So we have 2x squared y cubed z to the 6th power times the square root of 2xz. So that is how we simplify radicals by reducing the radicand. Thank you very much for listening.